The title of the presentation is Chart Common Mistakes. This presentation is a compilation of my experience in converting data to charts for many years. I divided common mistakes into two categories, one for type of chart and the other for the y-axis. I added two more sections, one for special types of charts that can be generated by Excel, and the other to show how to handle frequency curves for equal and variable bin ranges. The subtopics under types of charts are line versus scatter, column versus bar, clustered versus stacked, trend lines, pie donut, and sunburst. For the y-axis category, the subtopics are automatic scaling, secondary axis, logarithmic scale, and the two additional parts are special charts and frequency curves. For types of charts, this is a summary of the type of charts in Excel, and these are the types of data corresponding to the types of charts in Excel, and this is my own categorization where we put some column in black and some column in blue because the column in blue is in Excel after 2016. The line versus scatter, the line chart is characterized by same distance between markers, markers between tick marks, and the x-axis is used as labels. For the XY scatter, it is automatic scaling of the x-axis, and the distances are to scale, and it allows us to do curve fitting. This is a table for line versus scatter. This is a cross-section of one of the irrigation canals. If you do plot it using a line graph, you get this one, which is wrong because the distances are not proportional, even though it looks like a channel, but the correct drawing is this one by using the XY scatter. Column versus bar, they are the same, but the bar is rotated 90 degrees. The reason for doing that, in my opinion, is that if the x-axis label is long, it's easier to read if you use a bar instead of a column chart. Clustered versus stacked. Stacked adds two additional information. We can get the total value because numbers are stacked, and we can, by looking at the bar or the column, the stacked ones, we can see the relative amount of each item related to the total. Attention is needed if the total is 100, especially in percent. This example here showed a graph for post-secondary vocal education. We have two classes, general and technical, and it's a clustered column graph, but the two columns adds to 100. And as you can see, the x-axis titles are long text and they are 45 degrees, maybe difficult to read. Therefore, I converted the previous graph into bar 100% stacked bar chart, and I used, of course, the categories or the x-axis labels are easy to read. The next item is message from data and choice of axis. The choice of x and y axis, every choice you make, you send a special message, and there is an option in Excel that allows you to switch row and column. Like you can see, this is the cropping pattern of cultivated area in Mahmoudiyya watershed, summer 2018 Fiddan. Of course, the example extracted from irrigation engineering. We have 4 districts and 5 types of agricultural products. We can either plot it as stacked column to the left that shows how the different crops are distributed for the districts, and if we switch X and Y axis, we get how the crops are distributed for each of the districts. Trend lines is used when the values change with time or distance. Markers should be connected in this case to see rates of change. We use line graph if intervals are equal, and we use XY scatter if intervals are unequal. Like in this example, somebody was measuring pH values along the Rosetta branch at different locations characterized by unequal distances here in kilometers. Therefore, the choice of graph is wrong. He should choose an XY scatter because the distances are not the same, and of course a line graph, and we have to join the markers. If somebody decides to use a line graph, we can get something that is wrong. Why? Because the distances on the x-axis are not proportional. Pie, donut, and sunburst, three of them are circles, but they have different uses. Pie has only one series, and donut is the only way to compare pie charts, two or more. And sunburst is a different graph used for hierarchical data, which is the only chart in Excel where the table can include empty cells. This is an example of a pie chart showing the origination of tourists to the Arab regions, with small subcharts at the bottom of the slide showing how the Arab world and Europe countries are distributed. Here is the number of registered students in PhD and MSc degrees in one of the educational institutions, and we like to compare the numbers. We use a pie chart. Here, the PhD students with their numbers are in the inside pie chart. The MSc are in the outside pie chart. This is how data is arranged in the chart. The sunburst is hierarchical data. Hierarchical means something inside something big, inside something small, inside something smaller. Therefore, we have quarters, and inside quarters we have months, and inside months we have weeks, and the sales values are shown here. You will see that for the inside circle we have the quarter. For the one outside is for months, and the latest circle here is for weeks. The y-axis category, we have to watch for automatic scaling. Why? Because this is what Excel usually do, and it's used for comparing values of separate graphs. We keep the y-axis limits the same. It means, I'm going to give an example, but it means if you like to compare two things in two different graphs, you don't let x-axis does the automatic scaling. Why? To be able to compare easily. A good example for that is flows along the Blue and White Niles. You can see we have three sections at Morgan and Tamanniyat and Blue Nile, and to make comparison clearer, we had fixed the upper limit to 20. I think this is cubic meters per second. Secondary axis is used when the range of values in one axis is many orders of magnitude larger than or smaller than the other axis. If you can look here, we have drainage data, and from the eastern, middle, and western of delta, and we have two columns, one for flow in cubic meters per billion cubic meter per year and salinity in gram per cubic meter. And here you can see, if we try to plot the two columns, the column with the smaller numbers will be very close to the x-axis and we cannot read it. Therefore, we need in this case to have another secondary axis to allow us to read the smaller values, as you can see. Here also is a similar example, but we draw your attention to the dates if the x-axis is date. If the person who entered data let the computer know that the dates are labeled, this is what we are going to get. It will be like a line graph where the distance between the tick marks are the same, and the tick marks the distance between the markers are the same, and markers are between tick marks, and the y the values in the first column will appear on the y-axis. This is of course wrong. We have to enter January 15, February 20, and May 16 as date using the date arithmetic function, and this way you can get this graph, which is very much different from the one when we fail to enter dates in date format. Logarithmic scale, if the values on the y-axis differ many orders of magnitude, a logarithmic scale can be used. Therefore, we had in the previous example using a secondary axis, and another solution is used to a logarithmic scale. The secondary grid lines may be shown to facilitate reading the values. I am showing here an example to show you that they are not equal distances here because of the way the logarithmic work. Therefore, to enable people to read a logarithmic graph, it may be a good advice to plot this the differences in the gradation between 10 and 0 and between 10 and 100. This shows an example where we like to compare cost in Egyptian pounds per fiddan to number of contracts to area served, and because they are many times different in orders of magnitude, we use a logarithmic scale. The special chart, which is the first additional section here, shows a Gantt chart like produced by project management software like Primavera and Microsoft Project, but here I used a stacked bar chart, and I got rid of the lower part of the bar to be able to show the activities of the projects and which activities are critical and which are not. Here is irrigation seasons for the crops in winter and summer. It's an interesting example, again extracted from irrigation engineering, and also the stacked bar chart allows us to show very clearly the agriculture date and the harvesting date of each of the crops in winter and in summer. Here is also another different type of graph called the population pyramid. Here I used the stacked bar chart again to plot this population pyramid, and I had to put the number of females and number of males with different sign so that they give us the impression of the population chart or the population pyramid chart. Here, if we have clustered columns and we have stacked columns, but there is no type called stacked clustered columns among the options in Excel, and the way to do that is to arrange data this way and to have some empty cells so that the plotting will show the stacked clustered column as you see. Here there is a map chart in Excel, but I put this slide specifically to show you that you can do a map chart using Egyptian governorates, and this particular graph shows the desalination project under constructions in Egypt, and most of the project, and you can see, are on coastal governorates like Marsa Matruh, Ismailiyah, Sinai, Red Sea, and so on. Frequency curves, which is the last additional type of comments in addition to mistakes, where we need to plot a frequency curve using equal and variable bin ranges. Here is the example is extracted from my courses, where this is the student marks. This is a histogram chart. The histogram takes the first value and the minimum value and the maximum value and decides on the number of bins, and this is what I get. But I can change that because the histogram does that using the same bin range. Like you can see, it's 0, 1.4, 1.4, 2.8, 2.84.2. Here I can change the limits, but I cannot change the fact that the bin ranges are the same. Therefore, I go to the x-axis and I made the bin widths to 1. Therefore, I get a much better frequency curve for the quiz marks that shows a better performance of students than the previous automatic chart generated by histogram. But if I like to get the grade of the final mark grade in certain course, I cannot use the histogram, because the histogram, as you can see, cannot handle variable bin ranges, because between fail and pass is 50 marks, between pass and very good 15 marks, between very good and between good and very good is 10 marks, and between very good and excellent is 10 marks. And the only way you do this in Excel is not to use histogram, but use a frequency array formula that allows you to count the students for the different grades, and you get the frequency curve as you can see here in the bottom of the slide. My concluding remarks: in this presentation I compiled some common mistakes in using Excel to plot data under two categories, type of graph and the x-axis, and these two categories have sub-items that I went into detail to explain them to you. In addition, I showed how to generate special types of graph not in the Excel main types, and the last section shows how to handle frequency data in case of equal and variable bin ranges in Excel.